Okay, today is the day of doing numerical problems on the chapter work, power, and energy. Okay, so formulas and all you know. So we start straight away. Problems from page 252. Page number 252. Let us start with the question number 2. Question number 2. Question says a mass of 5 kg is lifted. A mass of 5 kg is lifted to a distance of 4 meter. Lifted to a distance of 4 meter. Vertically upwards. Vertically upwards. At a constant speed. At a constant speed. Number 1. What is the work done by the external force? What is the work done by the external force? And the second part, what is the work done by the gravitational force? What is the work done by the gravitational force? So, that is question number 2. We'll see the solution for first part. We are applying a force and lifting a body like this to a height given on here 4 meters. So what is the formula of work where you can directly write mgh. Effort we must give equal to the weight of the body mg. So mg into height. We will put the value mass given to us in the question is 5 kg. G value they are using is 9.8. Take G is 9.8. 9.8. It can be even 10. Height is given 2 meter. Sorry, 4 meter. Let us multiply and find the answer. Answer is 196 joule. Second part. Work done by the force of gravity. Work done by the force of gravity. That will be having same answer with the negative sign, because gravity is acting downward whereas the body's displacement is in the upward direction. Height is given in the upward direction. Rest of the thing remains the same, so minus and. Now next question number 3. Question number 3 of same page. Calculate the power supplied. Calculate the power supplied by a motor. Calculate the power supplied by a motor that lifts a mass of 50 kg. That lifts a mass of 50 kg vertically upwards through a distance of 10 meter in 1 minute. Question mark. What is the force supplied by the motor? What is the force supplied by the motor? Value of G given in the question is 9.8 meter per second square. G value is given 9.8. Let us do it. This is again a simple problem. We have to find power supplied by a motor that lifts a mass of 50 kg. Okay. To find the power, power formula is work upon time. Power formula is work upon time. Work will be equal to mgh on time. We'll put the value mass given in the question is how much? 50 kg. 50 kg. G value is 9.8. Height given to us in the question question is 10 meter. Time is 1 minute, that means 60 seconds. We are changing in SI seconds. Now we will cancel and find the answer. Answer will come 81.66. We are rounding off this much watt. That is the answer for the first part. Second part. What force is supplied by the motor? Right on force supplied by the motor. Force supplied by the motor will be, that is actually the effort, will be exactly equal to the load. So that F is equal to load is mg. What is the mass given in the question? 50, and the value of g is 9.8. Just multiply and find answer. Unit of force is Newton. There is a printing error in the book, so you can correct it. 490 Newton is also. Now we are doing the next question. Question number 6. A water pump driven by petrol. A water pump driven by petrol. A water pump driven by petrol. Raises water at a rate of 0.50 meter cube. 0.50 meter cube. At the rate of 0.50 meter cube per minute from a depth of 30 meter. Stop. If the pump is 70% efficient, what power is developed by the engine? What power is developed by the engine? The value of G given is 9.8 meter per second square. 9.8 ms minus 2. Okay. We will do this question. Meter cube is what? Volume. We can add information. Volume is given 0.50 meter cube. First we will be finding mass of water. Mass formula will be volume into density. D is density. Volume value for 0.50. Density is density of water because it's lifting water. So water density is 1000. It may not be given in the question. We are supposed to know that also. 1000 kg per meter cube. Multiplying this, the answer comes 500 kg. Mass is coming 500 kg. So we got the value of mass. We have to find power. Power formula we have work upon time. Work value will at mgh upon the time. Power. This will be power output. We can write here output power. This power is used in lifting. P, output power P. Mass P for 500, G value is 9.8. What is the height? It is raising the load to 30 meter from a depth of 30 meter. 30. Time given in the question is per minute. per minute is 60 seconds. We'll cancel. 3 2s will go. 2 and this will go 4.9. Multiplying this. Two four five zero watt. Two four five. Okay. Check the calculations. Calculation is 2450 watt. Yeah, this is correct. Now efficiency is given 70%. What is the meaning of efficiency? Efficiency means of the total power, 70% converts into the output power, means useful power. You can add 70% of the power supplied by motor equal to output power. Means only 70% of the total power supplied by the motor does the useful work, that means will lift the load. Here we have 70 by 100 into power supplied by the motor. This only we have to find. I like the P, or like the power supplied equal to output power we found 2450. Now we will find out the power supplied. Therefore, power supplied value will come 2450 into 100 divided by 70. I will find answer. This will become 3500 watt. That's the answer. If you want to change the answer in kilowatt, you have to divide it by 1000. So answer will come 3.5 kilowatt. This answer, which is given in the book. So this is also done. Now we are in question number 9. Question number 9. Question number 9. Question says, a body of mass 0.5 kg, a body of mass 0.5 kg, 0.5 kg starts from rest and slides vertically down and slides vertically down at a curved track, which is in the shape of one quadrant of a circle. One quadrant of a circle of radius 1 meter. At the bottom of the track, the speed of the body is 3 meter per second. 3 meter per second. So what is the work done by friction? What is the work done by friction? Okay. So how to do this problem? We'll draw a figure. Question says there is a quadrant of a circle. Quadrant of a circle we can make this way, make a quarter circle, or you can make it this way. Anyway, you make a quarter circle like this. There is a ball falling down and coming here like this. The ball is starting from top and reaching the bottom. And the question says, at the top of the track, the speed is 3 meter per second, and when it reaches the at the bottom of this at the bottom of the track, the speed of the body is 3 meter per second. Here the speed is velocity is 3 meter per second. And radius of the quadrant is given 1 meter, is also 1 meter. I will name it A, this point is B. Question is asking find the work done by friction. Work done by the friction, how do we find? We'll be finding this way. The energy at the point A and energy at the point B is supposed to be equal. But in this case, they will not be equal. We'll find the energy at A and energy at B. The difference of the two energy will be the value of friction. First, we'll write energy at A. Energy at A. What energy the ball will have at the point A? It is at height, so it will have only potential energy, like the mgh. Find the value. What is the mass of the ball given? Mass of the ball given is energy at A, and denote EAL, right? Mass of the ball given in the question is 0.5 kg. G value you can take 10. In the question it is given 9.8. You take 9.8, and the height is 1 meter at 1. Multiplying the things, it will be 4.9. 4.9. Energy at B we will find out. Energy at B. Energy at B, that is EB. What energy the ball is supposed to have at the bottom? Only kinetic, because there is no height, and velocity is this much, and at half mv squared. At half, mass is 0.5, velocity is 3 to 3. 9 5 are 45, half is coming 4.5. 2.25 joules. You find that 4.9 joule and it is 2.2. There is a difference. That means the friction is causing loss of energy. Therefore, work done by friction equal to minus 4.9 minus 2.25. 4.9 minus 2.25. That will give the answer. The answer will come 2.65. 2.65 joule. That is answer. Work done by friction is supposed to have actually a negative sign, but we are concluding answers, we will not give a negative sign. In the book they are given, you will be doing final energy minus initial energy, that means answer will come negative here. So that is also okay, but when you write in the words that is work done by friction is equal to 2.65, that is understood. That is work done by friction is having a negative sign. That is loss of energy. So this problem is done. Now the next question is over here. Question number 11 says a child on swing reaches a maximum height of 2 meters. Reaches a maximum height of 2 meters above its lowest point. Above its lowest position. Above its lowest position. What is the speed of the swing at the lowest point? What is the speed of the swing? What is the speed of the swing at the lowest point? Question mark. The value of G is given 9.8 meter per second. The value of G is 9.8 meter per second square. How to do? Swing is there, like this, and again coming back like this. At the bottom, it's moving and gaining height because of that. That is, kinetic energy is changing into the potential energy. We will make equation like a kinetic energy is equal to potential energy. This kinetic energy is only helping the mind to gain height. Kinetic energy is changing into the potential energy. kinetic formula we have half mv square. Potential energy formula will be mgh. M and M cancel. You have to find the value of velocity, the speed of the swing at the lowest point. That will be coming at 2gh. 2, the value of g is 9.8. And what is the height? The swing is raising to 2 meter. 2 meter here. 2 to the 4 into 9.8, 4 is the 32. 39.2 is the value of v square, therefore the value of v will come root of this 39.2, and if you calculate the answer will come 6.26 meter per second. So simple questions. Kinetic energy at the lowest point is changing into the potential energy at the highest point, the maximum potential energy. Okay, now we are doing another question, not from the book, so it is my own, so please write it down. This question is not in the book, write down. A body is moving in a vertical circle, of radius 1 meter, The speed of the body at the lowest point, is 2 meter per second. What is its speed? At the highest point. Question mark. G value you can take. G is given 10. Let us take 10. G is equal to 10 meter per second square. Okay. Now how to do this question? We will be drawing a figure like circle, vertical circle is made. The radius of the circle given how much? 1 meter. This is radius 1 meter. At the bottom here, the velocity is given how much? 2 meter per second. We have to find the velocity where it reaches the top here. Here the velocity is unknown. This velocity I write as v1 and not here the velocity I write as v2. This is going like this, continuous motion like this, vertical circle. You have to find the velocity at the another point. Velocity at one point is known and you have to find the velocity at the other point. Or to find velocity at any point. So to find the velocity will be making the energy value equals. I take this point as A, I take the value of this point as B. Right? Energy at A, total energy must be constant. I mean, law of conservation of energy. Energy at A must be equal to energy at B. You have to apply the law of conservation of energy. Energy at A, what energy it will have? There is no height. This is the only bottom point. That means the value will be half mv1 squared. Energy at B, what energy it will have? There is a height. With respect to the lowest point, there is a height out here. What is the height out here? Total height is 1 meter here and 1 meter here. That is total height is 2 meter. I write first formula like mgh plus height is there and as well as velocity is there. It is not stopping over here. Remember, it is still moving on here. It has got some velocity there. Half m v2 square I write here. v2 square. M common and cancelled. So it becomes like half v1 square is equal to gh plus half v2 square. Now we are putting the value half. v1 value is given 2, so 2 square that means 2 into 2. G is 10 and height from here to here. What is the height? 1 meter here and 1 more meter. That means 2 meter total height. Plus half v2 square. 2 and 2 will go. So I think we need to slightly correct the question. The height cannot be 2 meter per second over here. I will be increasing the value. I will take this as at the bottom the velocity or the speed of the body I will take as 10 meter per second. Here I will be writing a correction. With this correction I will write 10 and 10. 2 5 will go. It comes 50. 20 will come this side. Is equal to half v2 square. 30 is equal to half v2 square. Therefore v2 square value will become 60 and the value of v2 will become root 60. Root 60 answer we calculate using calculator. It will become 7.7 meter per second. That's the answer. I am not very sure about the calculation part. Root 60 answer you will find using calculator. It will become 7.7 meter per second. So we will be applying the law of conservation of energy. If you have to find a speed at any point, that means energy at this point must be equal to the energy at the other point. Okay. We'll take one more question. The speed of the bob of a pendulum. The speed of the bob of a pendulum at the lowest position is 2 meter per second. 2 meter per second. What will be its speed? What will be its speed when its string makes an angle number 1 60 degree, number 2 90 degree with the vertical, 90 degree with the vertical. Stop. Take the length of the string equal to 1 meter. 1 meter and G equal to the value of G equal to 10 meter per second square. Okay, that is the question. Now we'll see. We'll take a pendulum here, simple pendulum. At this point the velocity is given, that I'll take as v1. What is the velocity at this point given? 2 meter per second. Now it is going here and the string is making an angle how much degree? 60 degree. First case. It can be 30 degree even, any angle. So 60 degree the question says. Length of the string, this is the string. What is the length of the string given? 1 meter. This will also be 1 meter. This is the value of L. I'll take this point A and take this point as B. Velocity at the point A is known. We have to find the velocity at the point B. How do we find? We'll make energy equal. Right now, energy at A equal to energy at B. What energy we did have at A? Only kinetic. So half m v1 square. And at B it will have both the energy, right? mgh plus, because there is a height. With respect to this point, there is a height also risen, and then velocity is also there. Half m v2 square. M cancelled from both sides. Half v1 square is equal to g value is 10. Height I let as it is plus half v2 square. I put the value half v1 value. What is the value of v1 given 2? So 2 into 2. This will be 10. And how to find the value of height? Risen of it. To find the value of height, we will do like this. I I'm sure this height, this is the height, this height and this height will be same, this height and this height will be the same. How to find the value of this height, how to find this height? The value of this height will be equal to L1 minus cos theta, always, plus half V2 square. Why this will be like that? So I'll show you the reason why it becomes like this. The height reason will be equal to 1 minus cos theta. Why it will be like this? I'll show you the reason. I'll take this triangle out, right angle triangle here. This distance I'll take as x. This height I'll take as x. Use trigonometry, cos theta. This angle I'll take as theta. Cos theta will be base by hypotenuse, that means x by L. Therefore, the value of x will become L cos theta. This thing from here to here is again L only. But therefore, this is string, this is also a string L. What is the value of h coming? Therefore, h value is coming L minus L cos theta. If you take h common, L common, you get 1 minus cos theta. That's what I have written it here. So to find the height in this kind of situation, with the angle is known, we write directly L bracket 1 minus cos theta. Now we calculate the answer. These two will cancel. I think again slightly we have to make modification with the question out here. Otherwise the answer will come negative. So I will just slightly change the question. This value I will take as 3 meter per second. 3 I take. Here at 3 into 3. A correction, some modification I am making in the question. You can modify the question please. 9 by 2, answer is 4.5, 10. This is 1 minus cos 60. I do plus half V2 square. This is coming 4.5, 10. Cos 60 is half, so 1 minus half is coming another half, plus half V2 square, 2, 5, 10 can go. This value has to be more than this. I think I'll change it once again to 4. Write it 4. There will be the answer we match. Please, one last 10 corrections. This will come 8. Here the answer should not come negative, so that's why I am making some changes. So 8 minus 5, no, answer is positive. So 8 minus 5 is equal to half V2 square. 3 is equal to half V2 square. Therefore, the value of V2 will come root 6. So root 6 answer you will find will come 2 point something. So that much meter per second. You can use calculator for this part. So that is the answer. So the key point is the basic concept. When the angle is given, velocity at one point is known. How to find the velocity at the other point? We will make energy value equal. And find the height result in this question. Height result will be equal to L bracket 1 minus cos theta. That is the answer for the first part. Now we are doing the second part over here. Second part. This one is the 14 I have shown why h comes equal to this value. Second part we can do directly here. Still here the formula name is the same. I mean we write like this same way, half v1 square is equal to 10h plus half v2 square. In the second case I like half v1 value is 4. I have taken 4 into 4, 10. Height value again like L bracket 1 minus cos theta. Theta value is becoming 90 degree now. That means the string becomes horizontal. So cos 90 degree I write here. Plus half v2 square. Now I calculate the answer. This is coming 8. 10 L value is 1 cos 90 is coming 1 only. Plus half v2 square. That means okay, 8 minus 10 is coming half v2 square. This is coming negative 2 upon half v2 square. v2 square value is coming negative 4. Then v2 value is coming imaginary. v2 value is becoming minus 4. So that means the string will never become horizontal. You can write down. Hence the angle 90 degree is not possible. Hence the angle 90 degree is not possible. because the value of v is coming negative there, so that velocity cannot be imaginary number. So that is not possible. But the method of doing is like this only. That is, this system will never become horizontal. It will be somewhere in there this side. It will make some angle, some different angle. Okay, so this much is the problem for today. Next day we will be doing one or two more problems, and then we start new chapter, that is law of conservation of momentum.